You got to go. Yeah. Here's a practice for it. Yeah. Okay, surface area. I think it's just smart to review what the heck we're doing every day. What is surface area?
How much it covers up.
Yeah, total area of shape, how much it covers up. You're going to say all the same things. How much it takes to cover something. The first day we talked about, like, how much would it take to cover the top of this desk? How much would it take to cover a wall? We just did 2D objects. The last class that you guys had me, we did 3D objects. So now we upgraded it to how much would it take to cover this whole Kleenex box? Top, front, back, side, bottom. How much would it take to cover the whole thing? But that's what surface area is. How much it would take to cover a surface. To cover a surface. And in our last lesson, we did prisms. So we always had squares and rectangles. It was kind of nice. And then we did cylinders. So cylinders were like my coffee cup, right? Circle on top, circle on the bottom. And then we had that round label is what I called it. Cool. Today, what we're going to do is we're going to do more prisms, but this time without squares on the sides. And then we're going to do pyramids, which is kind of the same, and spheres, which is like a ball. And a ball just has its own formula and its own beast at the end of the day. Start off with what a prism looks like. This thing is a prism. The reason it's a prism is it has two sides, like a top and a bottom, that are the same, like this. My top and my bottom are the same. That's what makes something a prism. On the last day, it was like rectangles. The front and the back, or the top and the bottom, were always a square or a rectangle. Today is going to be triangles on the top and the bottom. That's all that's different. Our way of tackling it is going to be the exact same. You're going to try to picture it unfolded, and then you're going to break it down. Top, bottom, side, front, back, whatever you need to do. This prism is taken apart right here, so you can kind of see it. This is the top. So this top side right here is this top side right here. Bottom, bottom. And then you notice that you have your front. Your front side is actually a bit bigger than the other sides because the triangle is not equilateral. So our old trick of just being able to times by 2 isn't going to work anymore because our rectangles, you can see when they unfold it, aren't all the same size. And that's because all the sides on the triangle aren't the same. We have our back side back there. It's kind of hard to see. We have this area back here. That's this guy right here. And then our right side in here is our right side over here. I'm bad with the whole unfolding thing. That's just not how my brain visually works. But I understand that some people can picture something unfolded like nothing. It's called the net image, right? Unfolded into a net. Some people can look at that and know exactly what it is. Me, personally, I'm brutal at that. So you'll notice that I don't draw this very often. I kind of just do chunk by chunk because it's how my brain logically flows. If you really like the drawing of the nets, keep drawing the nets so you can see what every side looks like. All right. This is how I like to tackle it. I'm going to do the top and the bottom first. I know you got a lot of space there on the bottom to write things. Give me a second. So it says calculate side A. Side A is right here. For us, that's the left side. So it's this guy right here. If I want to calculate the left side, I look at that back door and I'm like, okay, that thing is a rectangle. I can see it's got a length and a width. Its length is 29. The width would be the height of it. The height of this prism is 40. So we're doing 29 times 40. I'm going to need a calculator for these because the numbers are getting kind of big. I guess it's written right in front of me, but it's 1160. And again, that's centimeters squared. Cool. The next side, they call side B. Side B for us is this front side. So I would call it the front. If I'm looking at that front side, I can tell that's a rectangle. Length is 31, width is 40, so I'm going to 31 times 40. When I put that in my calculator, 31 times 40 is 1,240 centimeters squared. If you're looking at your net, that was B. That was this big one right here. Awesome. The next side is side C. I would call that the right side. It's this one back here. Again, looking at that, that's a rectangle, right? I can see there's a rectangle there. The length is 20. The width is the height of that thing, which is 40. So it's 20 times 40, which should be 800. And we call that centimeters squared. The next two sides are going to be the same. So on a prism, you will always have at least two sides the same. Sometimes you'll get lucky and you'll have more. But the top and the bottom, kind of like the ends, should be the same. And if you look, our top and our bottom are these triangles, which I'll try to do in a different color. We'll do orange. This triangle and this triangle. They're the same. We're going to call it the top and the bottom. A reminder, when you go to calculate the area of a triangle, the area of a triangle yeah, you got it, is base times height divided by 2. On day 1, we did some of those like triangles, right? So you should have, that's a long time ago for some of you guys. That's like over a week ago. So the base and the height usually connects to a point of some sort, and the base goes across the bottom somewhere. If we're looking at our triangles, they've labeled this one really nicely for us to be able to tell what the base and the height is. The height would be 18 because it connects to that point. The base is the side length that connects to the height. So 18 and 31. So when I go to calculate the top and the bottom, I'm going to do base 31 times height 18 divided by 2. When you punch that in your calculator, you should get 279 centimeters squared. The bottom is going to be the exact same, 279 centimeters squared. Did I put a sheet on your desk? No. So this, like the strategy, I'm kind of putting it on and off, so now I'm just doing this when I go to people. Just cover my mouth. The strategy is kind of the same, right? Do every side one at a time. Yes, sir. Once you've done every side of the shape, remember our final job is to do the total. We have to add all those values up. So for us, we're going to add the left side, which is 1,160. We're going to add the front side, which is 1,240. Add the right side, which is 800. Add the top, which is 279. Add the bottom, which is another 279. And that should give you your grand total surface area. What it would take to cover that entire prism. You should get 3,758 centimeters squared. Like that. A lot like the last day. So whether I had you yesterday or I had you the day before, very, very similar. Figuring out the size is a little bit more challenging because it's kind of an uglier shape. It's not quite as nice as like a Kleenex box, but it's still the same idea. Yeah, man.
Will you mark it wrong if we don't have cm squared on the nose part?
That's a good question. So your question is like, do I have to have the units, right? Like, do I have to have this part?
For the answer, I get you, but before the answer, when you're doing
for the work,
yeah,
nah. So if like you're saying, if I'm showing my work on a test and I have the numbers, but I don't put centimeters squared in my work, is that okay? That's okay. I do want to see your units at the end, just so you understand like what this is. This isn't 3,000 miles squared, right? That's huge. And this is 3,000 centimeters squared. Centimeters are small little blocks. So then it kind of gives you an idea of what you're working with. You do hear about square miles sometimes, usually land, right? Someone owns a lot of land. They'll talk about how many square miles they own, or acres, which is like, I don't know how many's in an acre.
An acre is about kind of like a quarter of a kilometer.
A quarter? Quarter of a kilometer?
About that.
I thought it was half a kilometer.
Oh. I never know any of that stuff. Acre's big. That's what I know. Okay. There's one there. I want you guys to try that one. So go ahead on your own. See if you can find, there's 5 sides. See if you can calculate each of them. I will put the answer up on the board in a minute, but I want you to try on your own first. I'll label it maybe differently than you, but as long as you know what side I'm talking about, life should be good. So I would have called this the top. That's just my terminology. To calculate the top, I recognize that thing as a rectangle. It would be 5 times 7.5. If you put that in your calculator, you should get 37.5. The next side that I would have done is I would have done the left side is what I would have called it. My left side is this back here. It is a rectangle. You could have called it the back side too almost, right? Like it's kind of off to that left. That's a tricky one in my opinion because picturing the width, the bottom part of it, is sometimes easy to make a mistake. So this would be length of 4.5. Width is this dotted line. That dotted line is the same thing as 5. Those are the same. So that should have been 4.5 times 5. If you throw that in your calculator, you should get 22.5. Awesome. The next side that I would have done is the bottom. To calculate the bottom, again, we have a rectangle. This one's kind of probably the easier one to picture because both sides are nice and labeled for you. So that's length of 6, width of 5. So 6 times 5, you should have got 30. You then have your triangles. So you got the front side and the back side. That's what I would have called it. If you want to recognize that those things are the exact same, you're more than welcome. So I would have called that front and back. To calculate a triangle, you do base times height. In this case, the height is 4.5. The base is 6. So you're doing 4.5 times 6. And the thing that everyone forgets about triangles, divide it by 2. Right, so make sure you're dividing that thing in half when you have your opportunity. When you do that, you should get 3, 6, 9, 12, 13.5. And your back should be the exact same. $13.5 feels wrong for some reason. No, it is. It's 13.5. Awesome. Your last step, total it all up. 37.5 plus 22.5 plus 30 plus 13.5 plus 13.5 equals, what did we say it was? 117? Is that what we said it was? I'll do it again, but this time use my calculator. 117. And that's centimeters squared. If I was to guess where most mistakes happened, the triangles, right? The triangles dividing by 2 always gets people. They just forget. The other thing most people probably would get is this left side. That left side is hard to envision that bottom, what the width is. So if I'm predicting mistakes, that's probably where you made one. And those are kind of normal, everyday mistakes that everybody makes. If you're understanding everything, but getting like the wrong answer, so you're like, I did all this, but then I didn't get 2.5. I got something else. Like, that's positive, right? As long as you know what's going on. If you're sitting here being like, I have no idea what he's talking about, that's when you're in trouble, and you need to be like, please help me. I don't know what's happening. Okay, but if it's just calculation errors happen all the time. So don't sweat that stuff too much. Cool. Let's do pyramids. So, difference between a pyramid and a prism. A pyramid, all the sides are going to come to a point at some point. Where in a prism, you never had that like point that brought everything together. So if you look at this shape right here, you'll notice that on the bottom you have a square, but on the top you don't have a square. You have all of them going to a point. They're all connecting to something.
Do you have to worry about the rectangle, how high it is to the point?
Yeah, so there's certain things that you are going to need, and then there's going to be certain things you don't need. Like that height of the entire pyramid from the top point to the middle, they'll tell you that sometimes, and you don't actually need it.
Okay, so
yeah, they throw you off on some questions. So he's saying, well, do you need to know this height from here to the middle of the pyramid? And the answer is most of the time, no. It's just going to be extra information. What you do need to know, though, is something we call the slant height. So that's if you went from the top of the pyramid down to the middle of the outside. We call that the slant height. It's the same idea as being the height of the triangle on the side. The difference between a pyramid and a prism, if you look, a prism has 2 sides the same, right? And then everything's connecting to those sides. A pyramid's missing one of those. So it all folds into a peak. That's the only difference. Again, we have that drawing on the side, and I see some of you guys are drawing the net image. That's awesome. Keep drawing the net image if that helps you. Me personally, I'm so bad at that. So I just don't do it. But if you're good at it, keep doing this part. Okay?
Can I see calculations for the question?
Yeah, for sure. I'll just zoom out a little bit and scroll up. Oh, that might be too far. I'll give you those ones for now. I'll scroll back up in a second so you can see the last ones. The way we tackle pyramids is the same way. We're going to do one side, next side, next side, next side, next side. I'm going to start with the bottom because that seems like the easiest thing to calculate. The bottom, if I'm looking at this thing, is a nice little square. Length times width would be 6 times 6 would be 36. Since this is a square, that means that all these triangles are going to be the same. Now, typically, like the front and the back triangle would be the same, and the left side and the right side would be the same. But because it's a square, they're all going to be 6 across the bottom, and they're all going to have the same slant height. And that slant height is labeled as 12. Yeah. Yes, sir. So all the sides are the same. I'm going to calculate the front first. The front is a triangle, right? If I'm looking at that side, that's a triangle. So I need to do base times height. The height is from the very peak straight down to the middle. They haven't told me what it is on the front side, but they did tell me on the right side. My screen is going fuzzy because my internet's not good. From here, if you look at your paper, straight down, they told you that's 12. So they told you the height of the triangles are 12. Base times height, 6 times 12. Remember with triangles, divide it by 2. That's what we always forget. And you should get 36. The left side, the right side, and the back are all going to be the same. So left side is going to be 36. The right side is going to be 36. And the back is going to be 36. Because it was a square, all those triangles are the same. If you look at the fold-out image, you can kind of see, oh yeah, those triangles are all identical. They're all 6 by 12, 6, 12, 6, 12, 6, 12. Your final step is going to be to total it up. So we're going to have 36 plus 36 plus 36 plus 36 plus 36 for a total of 180 centimeters. Centimeters squared. If I just said centimeters, that'd mean all in a long row, right? Centimeters squared is talking about area. So that's telling me all little squares to fill up that whole space. Pyramids and prisms are basically the same thing. Like they're so close, right? So our strategy is the exact same. The calculations, the formulas, they're all the same. Pyramids, if you can do prisms, pyramids are usually pretty like, all right, I got this. There is one below right here. I want you to give that thing a shot. Then I'm going to go over it with you. Then I'm going to give you some time to practice. Then we'll do spheres together. If you missed that last question, there's some calculations for you. I got you. Starting up because I think that was a good amount of time. The first side I do with pyramids, I always do the bottom because I just find that easier. It also lets me look and be like, hey, is that a square or a rectangle? Because then that tells me what to do with my triangles. If I look at this bottom, I'm going to recognize quickly it's a square. That means all my triangles are going to be the same. Yes, sir.
Sorry, it's about the sphere.
Yeah.
Is there a unit of measurement we want to use?
If there's no unit, then don't do it. You don't need to worry about it.
We still have to do like answer square.
No.
Just to put the numbers in here. So the bottom of this thing would be 20 times 20, which would be 400 meters squared. Yeah, Ms. Giles is going to come around. She's going to hand you a formula sheet so that you have all these formulas nicely for you. On the sides, if I look, I've got this front right here. And I recognize quickly that front triangle is the same as the side and the back. They're all identical. I'm doing base times height. This is one of those questions where they gave you extra information. You don't want to use the inside height. You want to use the outside height. It's called the slant height. So you want to use the one that goes down the outside. In this case, it's 16.4 times the base of 20 divided by 2 should be 164 when you calculate it. The sides is going to be the same. So left side's 164, right side's 164, back side's 164. Your final job, total it up. And you should get, Kennedy, what did you get when you added it all up?
Which one?
I know you had it right. Number 4?
1,056.
056. Thank you.
Yeah.
And that was meters squared. Wicked. We're not going to do spheres yet. I'm going to pass you out a sphere. A sphere is a ball. Same idea. So even drawing them is hard because it just looks like a big circle. And so they'll always kind of have a dotted line around it to try to show you, oh yeah, this thing is a ball. our formula, thanks to Miss Giles saving me. So the area of a sphere, we said it was 4 pi r squared, correct? All right. Which is nice. I mean, anytime you see a ball or a sphere, you know you can just go straight to that. And it gives you a little bit of an easier time. Again, it is possible that you need to know the area of a sphere. So if you're thinking of, like, I don't know, a globe and you wanted to paint that globe, right? Like, how much paint do I need? That's how much surface area would you need. If you wanted to wrap it for some reason. So if you had a basketball that you wanted to wrap, I don't know why you'd want to wrap a basketball. I'm trying to think of something round that you'd want to put like a vinyl cover over. I don't know.
Paint a bouncy ball.
Yeah, paint a bouncy ball would work. Even if you want to cover a bouncy ball with tinfoil or something. An 8-ball, like in pool. Yeah, a pool ball, a bowling ball. Like, yeah, if you wanted to design a bowling ball, put a wrap or a vinyl over it. Yeah, it'd be the surface area of that.
Yeah, I'm just thinking you could
What a what?
put it in a box, like, instead of
Yeah, I would not try to wrap a ball. I'm with you. Anyway, with these spheres, you need to find the radius. Remember, the radius is halfway, so it's from the middle to the outer edge. That's your radius on a sphere. All the way across is called the diameter. We don't want that. We want half the radius. So when we do this calculation, area equals 4 times pi times 6 squared. If you're doing that on your phone, like if you don't have a calculator today or at home and you're just doing it on your phone, it might help to do the 6 squared first. Calculate what that is. Or rewrite it as 4 times pi times 6 times 6. Because that's what 6 squared is. It just means that it's times it again.
So you do 4 times pi times 6 squared.
Yep, because that's the formula, right? 4 pi r squared.
Was number 13 supposed to be written like that?
I'm not sure. I'll check after. I'll check. Gentlemen. So you throw that in your calculator, 4 times pi times 6. You should get that the area is 452.4. This doesn't have units, so we'll just leave it like that. Normally we would say feet squared, inches squared, whatever it is. Again, spheres, probably the easiest one if you remember to use the formula. We got a couple more spheres that we'll do together. Just getting used to that formula. If you don't know what pi is, if you don't have that button on your phone, use 3.14. That's fine. And that's cool with me. It should be pretty close. When you put 3.14, what did it get you?
I got it, man. 452.14.
It's pretty close. The decimal slightly up. On a test, try to use the pi button. If you don't have the pi button, maybe ask me and I'll help you out, or I'll tell you more digits of pi. 3.14, but it actually goes forever. So pi keeps going.
Well, I can tell you the numbers in the calculator.
That's what we'll probably do on a test so that people can use it. Okay, we got 2 more. I'll do this one with you. You do the next one on your own. So calculate the surface area of it says cylinder, but holy man, I must have had a rough day when I was making these. It's a sphere. You want to do area equals 4 pi r squared. They did not give you the radius. So this is one of those questions where they gave you diameter. So you have to cut it in half. Right? You take 26, you divide it by 2, and that will tell you that your radius is 13. That's probably the only thing they can throw at you that's hard. When you calculate it, that means it's 4 times pi times 13 squared. 4 times pi times 13 squared. Gentlemen. Boys. David. People around you are trying to learn, right? Hi. 2123.7 And that would be inches squared. I just put I in for inches. If you want to write out inches, that's fine too. So 2,123.7 inches squared. If you want to try number 7 on your own, I'll write the answer up on the board so you can check your work and see if you got it right or wrong. And then if you want to go back to your practice sheet, you guys got about 10 minutes before the bell goes, or until we dismiss. The bell actually goes a little bit after that because you guys leave early because you're grade 11s. See if you can't finish that practice before then. Okay, so go ahead. Our last answer is here on the board. So it would have been 4 times pi times 14 squared. You should have got 2,463.0, and that's centimeters squared.
And it's going to be a little bit different because we use
Awesome.